Alright guys, welcome back to TIS-100. It's been a rather frustrating game, so instead of streaming my whole progress, I'm gonna solve a problem first and then show you my logic behind the solution, sorry. So just because last stream, we spent a good 40 minutes of me just kind of bashing my head in, trying to sort out level 6. Now for today, I've just looked at level 9. It's a bit easier than the signal detector, so interrupt handler. Okay, so I've already got the code in here. Let me step you through what's going on. Okay, and I've also put some annotations so that you, if you're playing the game as well, you can kind of follow how I solved it. So what was the logic? First of all, I did this middle module. Really simple. All it does is, it adds all the numbers up. Oh, by the way, the aim of the game for this level is look for a change. If a number goes from 0 to 1, then you flag it. Then you send through number 1. Channel 1 has a change. Okay, imagine it's like a light switch. When someone switches on the light, you've got to notify the output. So over here, the output would be number 1. Over here, when the light switch goes on to 1, you've got to notify number 2. And the good thing is it only changes once every line, and so it's not as complicated, which is nice. So you can see in channel 4, you got to output channel 4, channel 3, and so that's the mission. Now, I did it in 2 stages. The first thing I did was to set up this middle one. I know it's not the most efficient one, but it's the clearest in terms of logic. That's how I solved it anyway. Alright, what this middle one does is, let's say the numbers 0, 0, 0, and 1 are fed through. 0, 0, 0, 1. All it does is it totals them up. 0 plus 0 plus channel 4 plus channel 3. Add them all up, chuck them down, and then you've got the total. Now, what I did was channel 1 chucks out the number 1 if it's true. If the light goes on, number 1 comes through. If the light goes on here, number 2 goes through. Number 3, number 4. So when you total it up, you will get 1 plus 2 plus 3 plus 4. But of course, only one light switch turns at a time, and so the number which comes out will be the output number. So that's this module. The bottom part just says, if true, tell me which channel is true. Okay, now let's go through this. This is where the hard work was. Alright, so we have to throw out a number 1, throw out a true number if the light goes on. But you don't want a true number when the light stays on, because that's the same, right? So you do need to save the number. So what I did was, I tried a few different models of trying to subtract 1 and work out when it goes on and off. Didn't work. In the end, what I did was, first of all, there are only really 4 different combinations, right? There's the light was off and is now off. The light was off and is now on. That's the true one. The light was on and off. We don't need to worry about that. The light was on and is still on. We don't need to worry about that. So the one that we do need to worry about is the light is off, was off, but now it's on. Okay? So that's what we call the true one. So then I use those 4. There's only 4 choices, so it means I can kind of test each one, and I found that to be easier than calculating when it goes on and off and do all that stuff. So here's how it works. First thing I did was check if the light was off. Check the current state of the light. When the number goes through, is it a 0 or a 1? That's nice and easy. So I just move the number into the accumulator, check if it's 0. If it's 0, it goes to this label here, which is 0. So what do I do? If it's 0, store the number in the backup, which is 0. Move it 0 down. The light's not on. Or it hasn't changed, sorry. It hasn't turned on, so it's false. That goes through. Then it goes back to the start. Now what happens if it was off, so the backup is 0, and the light turns on? Let's follow the logic again. Number 1 goes in because the light's on. Check if it's 0. It's not, it's 1, so the light is on. So it goes to our, so it's not 0, so it just follows this bunch of code. Swap the number. So the 1 goes into the backup because we need to keep remembering what the state of the light was, so we chuck it in the backup. Now check if the previous condition of the light was on or off. So since we swapped it out, the previous condition is now in the accumulator. So check if the previous condition of the light is off, which is 0. So if it's 0, then true. Then we go down to here. Okay, then you move 1 down because the light is on and it's true. We did switch the light on. Okay, now what if it was already on? So if it's already on, then the existing state won't be 0, right? So it would just go move 0 down. It's false. We haven't turned the light on. It was already on. So move 0 down, go back to the start. So that's the logic, and here's how it plays out. I'll step you through the first few steps. Number 0 goes in, nothing happens. All right, so here's where number 1 comes in. In channel 4, the light is turned on in channel 4. Number gets chucked into the accumulator. We check if it's a 0. It's not a 0. Okay, so then we keep going. The light has turned on. Swap the backup out. So now you can see that the state of the light is stored in the backup, and the old state, the history, what happened before was swapped out. Check if the old state was 0. If it is, then it's true. Then we move down here. Right, channel 4 gets put through because, channel 4 gets put through. So then this funnels through. We total them all up. 0 plus 0 plus 0 plus 4 is 4. That goes through as the output. There we go. Okay, so I'll just speed through that. Test 1, passed. Test 2, passed. There we go. Let's see how we went. Average, and slightly below average. Well, a win's a win. So hopefully you enjoyed that. That was level 9. Yeah, I look forward to